right, this is a video that goes along with 3.1, and I just want to talk about the methods of factoring in order to solve quadratic equations, and then completing the square, just as a supplement to the lesson we did. Okay, so let's talk about the factoring the method that when I would use guess and check. And that's when the leading coefficient, or the coefficient of the quadratic term, is 1. So let's start out with a simple example. Say I wanted to solve x squared minus 5x minus 6 equals 0. Again, this leading coefficient of the quadratic term is 1, so I know in this factored form, the only possibilities for the two spots in each parentheses are x and x. And so now for the last two spots, it has to be factors of negative 6. So we're either talking about 6 and 1 and 3 and 2. The problem with 3 and 2, and you need to figure out what factors are going to get me negative 5. So first you might look at 3 and 2, but the problem is, in order, if you FOILed it out to get negative 6, one would have to be positive and one would be negative. So that's not going to result in negative 5. So it looks like some combination of 6 and 1 should result if one has to be positive and one has to be negative. And since I want that middle term to come out to negative 5x, I'm going to put the negative with the 6, because that would be negative 6x plus x, which would give me negative 5x. So you always want to check your factoring to make sure that indeed, if you FOILed it out, you get back to the original. And now, once it's in that factored form and the other side is 0, you set each factor equal to 0 and solve. And it is very important to have that side, the opposite side of the factored part, to be equal to 0. Because 0 is the only number such that in order to get 0, one of the factors has to equal 0. The only way a product is 0 again is if one of the factors is 0. That is not the case with any other number. So you can never factor with the other side being anything but 0. For example, if the other side equals 2, it doesn't mean that one of the factors is 2 by any means. So again, you can only factor when one side is 0. Okay, let's try another. What if I had something like x squared minus 10x minus 24 equals 0? Again, leading coefficient, or the coefficient of the quadratic term, is 1, so that the first spots are easy. And now I'm looking at a little more possibilities for the last two spots. Because it has to be factors of 24, and there are many more of those. All right, so looking at this here, I want it so that, well, because it's going to multiply to negative 24, one's going to be positive, one's going to be negative, and I need to get negative 10. So from my possibilities, the only one that's going to work there, if one's positive and one's negative, is going to be 12 and 2. So, and I want the bigger to be negative so that I result in negative 10x. And then I set each factor equal to 0, and I solve. So x is negative 2 and x is 12. All right, so that's when the leading coefficient is 1. What about when the leading coefficient isn't 1? You can still do guess and check, but it can be a little bit more hairball. It can just take more time. Again, with a lot of practice, you can get good at that, and some of you may already be good at that, quickly able to spot number combinations. But if you would rather not deal with that uncertainty, another method is to first multiply the leading coefficient by that constant term. And in this case, I'm going to get negative 96. And the purpose is to rewrite the middle term, so then you can factor by grouping. So I want to figure out what factors of negative 96 will add to negative 29. And so sometimes this can take some time. Let's see if we can figure something out. So 3 goes in, so if I did 3 and 32, Okay, so 3 and 32 works. I swear I didn't know that ahead of time. 3 and 32. Okay, so if I did negative 32 plus 3, that would get me negative 29. Usually you don't luck out so quickly. Usually you have to try a few until you get there. Okay, so let's use what we just found. So again, the purpose is to rewrite the middle term. So I'm going to rewrite it as minus 32x plus 3x minus 8 equals 0. And notice that does equal negative 29. So I'm just rewriting the original problem so that I can factor by grouping. So in the first two terms, I can take out, let's see, the biggest looks to be a 4. And I'm left with 3, oh, and also an x, sorry. So 4x, and I'm left with 3x minus 8, which is perfect because that's what I have in the second grouping. So now what can I factor out of both of these terms? Well, I can factor out the 3x minus 8, and I'm left with 4x plus 1. Now it's in that nicely factored form, and I can set each factor equal to 0 and solve. So 3x minus 8 equals 0, 4x plus 1 equals 0, x is 8/3, x is negative 1/4. All right, so that is solving by factoring. Again, when the leading term is something bigger than 1 and not prime, you may find this second method to be helpful. So practice, it's good to practice using both, and I'll put up a sheet with more practice if people want more practice with factoring in general. Okay, so now let's talk about another method to solve quadratics, and it's called completing the square. And that's because if I were to get a problem like this, say I were to get x minus 2 squared equals 8. I would not FOIL it out and then bring the 8 over and factor. Instead, it's already in a form that I can solve by taking the square root of both sides. Remember, when you solve by taking the square root, it's plus or minus. So x minus 2 equals plus or minus 2 root 2, and x equals 2 plus or minus 2 root 2. So if I have a perfect square on one side and a number on the other, then this is going to be pretty easy to solve. So that's another method to solve quadratics, is we can force it to look like this. So let's do an example. Let me just make something up here. How about if we have, let's make some room, x squared, actually I'm going to start out like this, 2x squared minus 6x plus, let's do plus, actually let's do minus instead of plus, sorry. Just trying to think, want to make sure it works over the real numbers. Let's do minus 7. Something it's not going to be factorable, so if it's not going to be factor when we complete the square, it should end up with square roots here. So let's do this. All right, so here are the steps to completing the square. And I purposely made the coefficient in front of the squared term not be 1, because if it's not 1, there's something you have to do. So let's go through. So might as well do the most complicated type. So again, the goal is to get a perfect square on one side, a number on the other. Okay, so first thing I'm going to always do is bring over the constant term to the other side. So I'm going to bring 7 over. And in order to complete the square on the left, I need to factor out the 2, because I can't complete the square until the coefficient of x squared is 1. All right, so factoring out the 2 here, I get x squared minus 3x. Again, remember, we're not changing this equation, we're just manipulating it. So we've got a perfect square on the left and a number on the right. So it's a good idea to double check if I were to distribute the 2. Do I still have the same equation as above, which I would, 2x squared minus 3x. All right, now for the completing the square part. So to complete the square, the process to make that perfect square is I'm going to half the linear coefficient. So this linear, and notice I'm putting a lot of mathematical language in here, which is very important, and I'll continue to do so. So hopefully you'll get the hang of it. X is a linear term because it's x to the first. So when I take half of the linear coefficient, a coefficient is always a number in front of a variable. So half the linear coefficient would be -3/2. So I'm taking half of that, and then I'm going to square that. And that's what I'm going to add. So I'm going to add 9/4. Okay, so notice, though, when I added 9/4 in that parentheses, how have I really changed that left side? So if I were to FOIL out the left side, I get 2x squared minus 6x plus 9/2. So even though I've added 9/4 in the parentheses, I've actually only changed that side by 9/2. So it's important to recognize that, because whatever I do on the left side, I have to also do on the right side, because I can't change the equation, right? So I'm gonna add the same thing to both sides. So again, I actually added 9/2 to the left side, 2 times 9/4. So I'm gonna add 9/2 to the right side. All right, so let's see why this is helpful. So now on the left, I can rewrite this x squared minus 3x plus 9/4. Well, I've just actually created something that factors to a perfect square, and it factors to x minus 3/2 squared. And that would be, if I FOIL that out, I could get x squared minus 3x plus 9/4. Good trick is, if you've done it correctly, then it's always going to be x plus, the complete square is always x plus whatever you got when you halved the linear coefficient. In this case, I got -3/2. Okay, so 2 times x minus 3/2 squared equals, let's just write 7 9/2 as an improper fraction. So 23/2. All right, and now I can't take the square root of both sides yet, because remember, I want the perfect square on the left. I've got to divide both sides by 2. Equals 23/4. Now I can take the square root of both sides. X minus 3/2 equals plus or minus the square root of 23, and 4 comes out as 2. So my final answer here would be x equals 3/2 plus or minus root 23/2. All right, so that's kind of one of the more harder ones. You had a coefficient in front of the x squared that I had to factor out, dealing with some fractions. But that's the process there of completing the square. Maybe let's just do one more simpler one, just so I can go through the process one more time of completing the square. Say it was x squared minus 4x minus 7. Again, something that is not factorable. No factors of 7 are going to get me -4. So this time, the nice thing is the coefficient of x squared is 1, so I don't have to factor anything out before I go about completing the square. I bring the constant to the right. I half the linear coefficient, and then I square it, and I get 4. So I'm going to add that to both sides. Remember, I don't want to change it. I'm just manipulating it. And so now on the left, I can write x squared minus 4x factors to a perfect square. X minus 2 squared. Again, notice it was plus whatever the half the linear coefficient was, equals 11. And square root of both sides, and then I can bring the 2 over. And that's completing the square. Some people end up really liking it. There's just, depending on whether there's fractions involved, there can be some rooms for error.